You know, we see them every single day. Cars. They feel so familiar, right? Almost simple. But behind that sleek, painted metal is this whole world of incredible engineering. And today, we're going to pull back the curtain on one of the most important, yet totally overlooked, secrets to how they're made.
No, seriously, have you ever really stopped to think about it? A car doesn't just appear. It starts its life as flat sheets of steel and aluminum. So how in the world does it get those curves, those sharp angles, that incredible strength? How does it go from being a flat piece of metal to a three-dimensional machine that keeps us safe at, highway speeds?
So what we see is just the final product, right? This seamless object of design. It's engineered to be aerodynamic, strong, and, well, beautiful. But that flawless surface, it hides a pretty powerful secret about how it all comes together.
It all starts right here. This is what's called the body in white. Basically, it's the bare metal skeleton of the car, before any paint, any engine, any seats are added. Every single structural piece you're looking at right now, it was once a totally flat sheet of metal. So the real mystery is, how are they all bent into these exact shapes to form this incredibly rigid protective cage?
Well, the answer lies with a true unsung hero of the factory floor. We're talking about a machine that's been around for a century, but believe it or not, it's more critical today than ever before. It's time to meet the press brake.
So what is it? What does it do? Well, to put it simply, a press brake is a machine tool for bending sheet metal. The best way to think about it is like a massive, incredibly precise, and super powerful karate chop for steel. A ram comes down and pushes a sheet of metal into a die, and boom, it creates a perfect bend, over and over and over again.
And man, this machine has had quite a journey. It all started back in the 1920s as just a big brute force mechanical tool. Then, you fast forward to the late 20th century and hydraulic controls made things a lot more predictable. But today? Oh, today's press brakes are a whole different ballgame. We're talking high-tech, CNC-controlled, totally automated systems that are right at the heart of the modern smart factory.
Okay, so it bends metal. Big deal, right? Who cares? Well, it turns out that the precision of that bend is absolutely 100% critical. The stakes are incredibly high, and trust me, this is where the story gets really interesting.
Just look at this number, plus or minus half a degree. That's it. That is the razor-thin margin for error in modern car manufacturing. I mean, it's tiny, and if a single bend is off by more than that almost nothing amount, it can set off a truly catastrophic chain reaction.
And here's exactly how that ripple effect works. It starts with one bad bend. That means the part won't fit perfectly where it's supposed to go. Then the robotic welders can't do their job right. They either fail completely or create a weak joint. All of a sudden, the car's entire structure is weakened. And a weak structure? That means compromised safety in a crash. It all cascades from one tiny, tiny error into a massive potential failure.
And this is why this matters to you and me. That incredible precision from these press brakes, it's absolutely essential for car makers to meet the super strict crash test standards set by global organizations. Like the Euro NCP in Europe or the NHSA here in the States. That 5-star safety rating that you look for when you buy a car, yeah, that starts with a perfect bend. But this story isn't just about the cars we're used to. This same century-old technology is now right at the absolute forefront of the biggest shift in automotive history, the EV revolution. Because, you see, the parts needed for an electric vehicle are fundamentally different. We're not just talking about bending things like chassis reinforcements and engine mounts anymore. Nope. The new mission-critical parts are things like battery trays, cooling channels, and housings for all the high-voltage electronics. And guess what? These parts have even stricter requirements. Let's dive a little deeper on this. The battery pack is basically the heart of an EV, right? Well, its housing is its suit of armor. And these massive aluminum trays have to be perfectly rigid to protect all those battery cells from damage. The cooling channels running through them? They have to be bent with absolute consistency, or else you risk overheating. The entire safety and lifespan of an EV's battery literally depends on the precision of these bends.
So it's clear the press brake is still incredibly vital. But it's not just some standalone machine sitting in the corner anymore, not by a long shot. Today, it's a key player in the super high-tech, automated, and data-driven smart factory of the future.
I mean, just think about the impact of automation. In the olden days, changing the tools on a press brake to make a new part could take an entire hour. An hour. Today, with automatic tool changers, it takes about 3 minutes. That's a reduction of over 90%.
It allows factories to be unbelievably flexible and just pump out all sorts of different parts on the very same line.
In today's press brake is a fully connected part of the whole production line. We're talking robots loading and unloading parts, smart sensors, the whole industrial Internet of Things that can predict when maintenance is needed before the machine ever breaks down. It syncs up with the factory's supply chain software, and now AI, artificial intelligence, is even helping to optimize the bending process itself, making the whole thing smarter and more efficient than ever.
So what this all boils down to is this. As cars become lighter, more electric, and eventually autonomous, the demand for these perfectly formed metal components is only going to grow. The vehicle of the future, it's literally being shaped by this unsung hero of the factory floor.
Kinda makes you wonder, doesn't it? What other seemingly simple, totally overlooked technologies are out there, acting as the hidden foundation of our modern world? What other unsung heroes are quietly shaping the future right in front of our eyes?